Good day to all of you. Today we shall discuss on the topic set-associative mapping, which belongs to cache memory and mapping functions topic. So in cache memory and mapping functions, already I have covered two mapping functions. One is direct mapping function and another one is associative mapping function. Out of three, two are covered, and this is the one last remaining, set associative mapping. Okay, so the example which I have taken in those two, the same example I have taken here, so that when we study we can compare them very easily. So the example here is for two-way set associative mapping, right? In set associative mapping, again we have different kinds. One is fully associative mapping, another one is two-way set associative mapping or four-way set associative mapping, depending on how many blocks in each set in the cache. So it is called as L-way set associative mapping also. If L is 2, then it is called as two-way set associative mapping. Hence there are two kinds. One is fully associative mapping, another one is L-way set associative mapping. In L-way set associative mapping, because L is 2, we are considering in the example two-way set associative mapping. So the parameters which I had taken in direct mapping and associative mapping regarding memory size, the same parameters I have taken here. So word size is 1 byte, that is assumed. Main memory size 4 KB, means 4 kilobytes. Cache size is 512 bytes. Block size is 4 words. Because each word is of 1 byte, we can say 4 bytes. Okay. So with respect to this figure for main memory and cache memory are drawn here. So what is shown in main memory diagram here? So this is block 0. This is block 1. So like that, the last block is 1, 0, 2, 3. So what is block? Block is a group of words. So 1, 2, 3, 4. How many words are in each block? 4 words are there. So because each word is equal to 1 byte, so 4 bytes. This group of 4 bytes is called as one block. So like that, totally from block 0 to block 1, 0, 2, 3, how many number of blocks we have? 1024 blocks. So 1024 means it is 1K blocks, right? That is regarding main memory. So as per given size 4 KB here, this 1024 total number of main memory blocks in each 4 words means 1024 into 4, that will be equal to 4 KB only. So using this main memory size is 4 KB and block size is 4 words or 4 bytes. This main memory diagram is drawn here. So then this is the diagram for cache. So here also block 0, block 1, block 127. So the first one is block 0, the last one is block 127. Totally how many blocks are in cache? 128 blocks. Okay. So in each block how many words? 1, 2, 3, 4. Why? Because in main memory block 4 words. Main memory block and cache block have to be of same size. Right? Because in each block 4 words here or 4 bytes. Here cache size is given 512 bytes. One block size is 4 bytes. Hence number of blocks in cache is 512 divided by 4, it is 128. Hence from block 0 to block 127, totally 128 blocks we have in cache. So that is second point. And here we are showing set of 2 blocks. Block 0, block 1 together forms one set. Then block 2 and block 3 will make second set. Like that, last one, block 126 and 127 form set 63. How it is set 63? So 0 to 128 total number of blocks in cache. Because it is two-way set associative cache, here in every set 2 blocks are there, totally 128 blocks. So 128 by 2 means we'll have 64 sets. Hence here set 0, that is 2 blocks in this set. Like that in every set 2 blocks, if you have 128 by 2, that is 64. The last one is set 63, because numbering starts from 0. Each set 2 blocks will be there. Then what about this? This shows physical address division. So this is main memory address, physical address of word in main memory, that is given here. What does it mean? Whenever processor asks for a word, then it sends the physical address of the word in main memory. Suppose the word is here. Then instead of one word being copied into cache, then whole block will be copied into cache block. Okay. So then how many words are here? So 4k words are here. 4kb byte means word. 4k words are there. Any word when asked, its physical address is given. Then what will be its address? So this whole shows the physical address of one word in the main memory. It is divided into 3 parts. The first one is stack, second one is set number, and third one is word offset. Okay. Next we shall see what these do mean. So set number means whenever a block is copied from main memory to cache, it is copied in a particular set. So whenever a block is copied in a block of cache, so where it is copied? So it is copied in a block of set. In which set? That is calculated by the formula like direct mapping. Suppose if it is calculated to be set 0, then there are 2 options for that. It can be either copied in block 0 of cache or block 1. If block 0 is full, it will be copied in block 1. If block 1 is full, it will be copied in block 0. There are 2 choices for that. So hence it is flexible like associative mapping. So the set number, so the block number in cache in which it is going to be copied, in which set it belongs to which set it belongs to, that is calculated by strictly using a formula like direct mapping. But in that set where it is, copied, in which block it is copied, there is choice. Hence it is flexible like associative mapping. So then what is set-associative mapping? Set-associative mapping is the combination of both direct memory mapping and associative memory mapping. It is strict like direct memory mapping, wherein a main memory block is copied into a block of cache which falls in a calculated set number, which is calculated by a formula, right? Then it is flexible because in calculated cache set number, in any freely available block in that set, main memory block can be copied. So in set-associative mapping, strict calculation for the set number using a formula like direct mapping, and the choice for the blocks in that set like associative mapping, both are present. Okay, hence set-associative mapping is the combination of both. So here in the example which is taken, two-way set-associative mapping which is considered, already discussed. Two-way means there are 2 blocks in every set in the cache. As per data, cache size is, that is total of 512 bytes. Block size is 4 bytes. Hence number of blocks in cache is 512 by 4, that is 128. because the two blocks in a set, the number of sets in the cache will be 64. That is set 0 to set 63, which was shown in the diagram. So the next question that we must be able to answer in set associative mapping is, if this is the physical address or main memory address, okay, that is the address of one word in main memory. So it is we already know that it is divided into three parts: tag, set number and word offset. So in physical address, then how many bits are there for each part here? Okay, that is called as physical address split. How to find physical address split, right? So in main memory, the size is 4 KB, means 4 kilobytes, right? So it can accommodate 4K words because one word size is 1 byte there. So totally how many words then? 4K. So this 4K can be written as this 4 as 2 raised to 2 into this K as 2 raised to 10. So this is 2 raised to 12 words. Okay. Hence to address each word, 12 bits are required. Hence in physical address of the word, how many bits will be there? Totally 12 bits will be there. This is the total size, right? Then what is word offset? So the word offset means in each block, how many words can be accommodated? 4 words can be accommodated. So to address any one word, then 4 can be written as 2 raised to 2. Hence 2 bits are required to address any one word in the block. Hence word offset is of 2 bits. So out of 12 bits, now 2 bits are there for word offset. Then what about set number? Okay, how many bits are there for set number in the physical address? In cache, there are totally 64 sets. So then 64 can be written as 2 raised to 6. Then 6 bits are required to address any one set in the cache. Hence, the bits for set number is 6 bits. Now out of 12 bits, 6 bits for set, 2 bits for word offset. So 6 plus 2 is 8. 12 minus 8, that will be 4. This is for tag bits. This is the physical address split. What does it mean? So whenever main memory sends the physical address of the word in main memory, so the block containing that word in main memory, that is copied into a block of a set. Which set? That is indicated by these 6 bits in the physical address. So in that set only it is copied. And how this is obtained internally? That is by a formula like direct mapping. Okay. Then in that block, which word the processor was asking for? That is indicated by these 2 bits. Is it 0, 0? Is it 0, 1 or 1, 0 or 1, 1 word in that block? Then this tag bit indicates, this tag part or tag bits indicate which main memory block is being copied into a block of set in the cache. This is what is physical address split. Okay. If the processor requested word is in this block of main memory, then this whole block is copied onto particular set block in the cache. Which set? That is calculated by a formula, right? What is the formula? This block number in main memory, that is 0 mod total number of sets in the cache, that is 0 mod 64, that comes out to be 0 only. Then this block will be copied into the block of set 0. So in any one of these two blocks it will be copied. If block 1 is copied onto cache, so 1 mod 64, that is 1 only, hence it will be copied into a block of set 1, right? That is either block 2 or block 3. There is a choice now. This is how, like direct mapping, it is calculated and it is strictly copied onto that cache block only. Because there is choice now, it is flexible like associative mapping, right? With this main memory block number 0 mod 64, this is total number of sets in the cache. What is the formula here? Main memory block number mod total number of sets in cache. So here that will give set number in the cache. So 0 mod 64 is equal to 0. Hence it will be copied into set 0 block. Like this it is strictly calculated as per direct formula, and in that set there is a choice is there, it is flexible like associative mapping. Okay. So what was the topic? Set associative mapping, which is the third mapping function. There are totally 3 mapping functions. The first one is direct mapping, second one is associative mapping, and third one is set associative mapping. So for direct mapping and associative mapping, you can refer to my previous videos. That completes the discussion. I hope you understood. Thank you.